Hi everyone, Maciej here. I'm the CEO of APIS Training. I would like to welcome you to this webinar. Today we have the participants from many countries around the world. Obviously the topic we will cover attracts lots of attention. And now the moment we all been waiting for, Martin Franzén.
Right, thank you so much, Maciej. Hello everyone, my name is Martin and I'm an instructor here at APIS, and I will be your guide through this whole jungle of 5G radiation and possible health hazards. Now, during this talk you will have the possibility to ask questions. I won't answer them though until the end, until I've spoken for around 45 minutes. So we have a moderator here. Søren, would you like to step into frame and say and wave to the people?
Hello.
This is Søren. Right, thank you so much. So Søren will be collecting your questions. The means you have to ask these questions is the Q&A button right at the lower part of your screen somewhere. There is a chat button and a Q&A. Please use the Q&A because it makes it simpler for us. Q&A, that's for questions and answers. I can answer one question already that some of you might have, and that's whether you're going to get these slides afterwards and whether you will get a recording of this afterwards. And the answer to both of those questions is yes. You will get an email with some form of evaluation, and you will get the material that I've been showing, and you will also get a link with which you can look at the recording of this webinar. So let's get to it. Is 5G dangerous? Yes. Okay, thank you. No, it's actually a little bit longer than that. So this is APIS tries to be clever. And I would like to preface this whole talk with the fact that we are not practicing scientists. We are not medical, we're not professional physicians. What we are is we are engineers. We're quite good at reading scientific things. Our line of work is very much evidence-based. We couldn't do what we do otherwise. We read technical and scientific papers all day long, albeit not normally sort of health-related papers. So we have the science side, and we also have the telecommunication radio-y side, because we've been going from 2G, 3G, 4G, and now 5G, so we have drawn one or two radio waves on whiteboards over the years. So this is us trying to be clever. Oops, hang on, I'm gonna just change little thing here to make the audio a little bit clearer. So the question is, have you seen these people? Stop 5G, Cell no, healthy fiber. Why are they so upset? And should they be? Perhaps it's just the case that people like to make signs. Well, it does seem that way. I particularly like this one. I am a little upset. I also like this one up here. What do we want? Time travel. When do we want it? It's irrelevant. That's fun. Also, you can ask the question, have there been similar signs to the 5G signs earlier in time? And lo and behold, there have. You can go back in time. Well, you can't go back in time, but you can virtually, internetally go back in time and look at 4G scare signs and 3G scare signs and the likes. So it's not a particularly new kind of panic. So what I'm going to be doing during these 45 minutes is I will be telling you, what do we know? Who am I to stand here? A little bit about science background, because this is all very science related. 1G through 4G stuff, essentially, the generations of mobile telephony that have already been. And then add 5G, and you will see why we take it in this order in a little while. Then dead birds, non-humans, and finally a conclusion. So here we go. What does APIS know? Well, we know everything that is Googleable. We know everything that is PubMed searchable, and if you don't know what PubMed is, you should. If you are interested in any kind of health-related science, you should look up PubMed, because that's a database where a lot of the world's scientific papers on health matters are published. Well, they're published in journals, but you can find the articles of those journals through PubMed. PubMed is the database where you can search for these articles. So that's an excellent resource for the kinds of things that we'll be discussing today. And everything 3GPP findable. So that's where our normal home is. We read these things, you know, every day. That's essentially our livelihood. We actually take the time to read these 3GPP papers because no one else wants to, and then we make them into colorful pictures and have people come to our training. But that's about it. That's what we know. So if you have questions during this talk or after this talk, it's not unlikely that you will have a question of the kind, but I've read this thing, or have you seen this article? And if you have that kind of question, it's very likely that my answer will be no, I haven't seen that article. It would be disingenuous of me to pretend that I have, but I would be happy to read that article and engage in a discussion with you afterwards. So just to sort of prepare you mentally for our approach. We have done our best. This is us showing you the results of us doing our best. So the central question, have previous generations of mobile technology been harmful, so 1 through 4G? If yes, do those harmful elements still persist in 5G? Seems reasonable. If it's already dangerous, maybe 5G is also dangerous. Or if 1G through 4G is not dangerous, then is there anything new with 5G that introduces something that is dangerous? Science is the method that we use to find out things about the world. Science has a very good track record. It's been around for a couple of 100 years, and before that, people just sat around saying we're going to think up the answers, or we're not going to try it, or we know everything, let's not try to even look for answers. I will show you a short funny clip from a guy, you may have seen him around. His name is Richard Dawkins. He's a very well-renowned British professor. He's an evolutionary biologist by trade and has written lots of books. He's the guy who came up with the word meme, by the way. That's him, he invented it. And this is a short clip from him answering the question why science is a good method to answer questions as opposed to other, like, I don't know, magic stones or eating mushrooms. So here we go. This is him answering that question.
Yes.
Basically, what he said.
It works. It works. Planes fly, cars drive, computers compute.
It's an inductive argument.
If you base medicine on science, you cure people. If you base the design of planes on science, they fly. If you base the design of rockets on science, they reach the moon. It works, bitches.
It's an unexpected utterance from this very, very British person, but there you have it. It works, bitches. Richard Dawkins. So go buy your t-shirts now. It has a very good track record. In science, we need to talk about dose. If someone says 5G radiation is dangerous, that's a completely meaningless statement unless you say how much of it. That's the case for everything. It's not special about radiation. Dose is what makes something lethal, and it's what makes something harmless. So everything is both lethal and harmless. A while ago, if you wanted to freshen up, you could use Dr. Sim's arsenic complexion wafers because, you know, goes nicely on your skin. That was then. Nowadays, if you ask the US Environmental Protection Agency, the EPA, they say that this is the amount of arsenic that is okay in your drinking waters, notably more than 0. Of course, you can have a goal of 0, but this is also okay. So if you take a molecule of anything, it won't kill you. And on the flip side of that, if you take enough of anything, it will kill you. This is a picture from the Wikipedia page on water intoxication. That is, going sick or even dying from drinking too much water. And this, unfortunately, is a clip from the news reporting of a lady who did just that, died from water intoxication. Even more tragically, in a contest trying to win a Nintendo Wii. So, we need to take those into account. We can't say radiation is dangerous. We have to say how much of it. And so we'll come back to safety levels in a little moment. Science works by testing things. We form a hypothesis. This is what I think, this is what I believe, and then you do your damnedest to falsify it, to try to prove yourself wrong. That's how science is supposed to work. You can do it in different ways. You can do it with direct experiment. You can 5G radiate someone and see if they fall over or vanish in a puff of smoke. Maybe that's not a super ethical experiment to do. And if you can do it, it's also ethical debate whether it's okay to do it on mice and rats, but that is being done. So we have the reports on that. If you don't want to do it on anything living, you can just look at the history of things. Just look back in time, look at a large population of people over a large amount of time and see, okay, so what did they do and did that do them anything good or bad? This is called epidemiology with a fancy word. So this is essentially statistics over populations over large amounts of time. So we'll come back to look at what the epidemiology of cell phone radiation is as well. However, you have to be aware that there is a trap here, because if you draw two graphs and see that hang on, they follow each other, A and B seem to happen at the same time, you may erroneously draw the conclusion that A causes B, that there is some kind of causation here, not merely correlation that they seem to sort of follow each other, but there's actually a causative connection between the two. If that were the case, then this would be true, that the age of Miss America correlates with the number of murders by steam, hot vapors, and hot objects. And you can see it in the graphs. These are real numbers. They do correlate. If you're not convinced, let's look at the divorce rate in Maine, in the state of Maine. It correlates to a degree more than 99% with how much margarine is consumed in the US. That's weird, isn't it? And did you know that the number of people who drowned by falling into a pool correlates very, very well with the number of films that Nicolas Cage appeared in during that year? This is correlation, but it's not causation. If you followed this further on in time, you would see that they go apart. This is just a matter of being able to look at large enough data sets, and if you have large enough data sets, you can find correlations. You can't predict which correlations, but if you have enough variables, you will be able to find correlation. Okay. So, in sort of finishing off the science part, I just want to make a note here of the difference between science-based and evidence-based. I talked about evidence and using evidence and collecting evidence, I suppose. It's not unusual to read in papers things like scientists have shown that stepping on a banana peel causes cancer, or some other ludicrous thing. Just science has now shown that. And what they do then is that they report what one research group have just published. That research group doesn't need to be very serious or have very good evidence for what they're claiming, and also their conclusions don't need to be at all in line with the large chunks of evidence we already have that may be pointing in another direction, that we don't contract cancer by stepping on banana peels. So evidence is sort of one by one. It's not difficult to go to PubMed, you know, the database that I just talked about, and find evidence of almost anything you'd like. Because let's face it, there are good reports and there are bad reports. Some are done with very high scientific rigor, and some are done without controls and fudging with the statistics and so on. It still gets published. That's why science is important, because science is the method by which we weigh all these evidence together. We find a consensus. We look at where the big arrow is pointing, the big arrow formed by all the small arrows of evidence. And there will always be small arrows of evidence pointing in the other direction. And it would be a better world if all evidence pointed in the same direction, but that's just not the way it is. So I won't if someone wants to sort of find an article that points in another direction that I want talking right now, I'd happily read it. But I'd still urge you that we need to look at the conclusion of the mass of evidence. So evidence-based medicine as opposed to science-based medicine, which is also the name of a very good blog that I recommend you read. So 1G to 4G stuff, that was all, you know, what science does very, very briefly and how it does it and why science has a very good track record. It's always fun to see people sort of dissing science and saying science doesn't know anything. I'll show you that the earth is flat. And they do that while using science in like 99% of their life. They're doing that using their computer. They go to the studio with their car and they have clothes made from the results of science. So all other science is okay, except for the ones that they disagree with. I have to just put it plainly like this. Right now, there's nothing that supports the claim that cell phone usage is harmful to humans for older generations of telephony, or cell phone use. Usually, the crux of the matter is ionization. Ionization is what kills you, you could say. Ionization is this. So let me just zoom in a little bit here. This is an atom. There's lots of pluses, positive charges here in the nucleus, and lots of negatives, electrons flying around here, and it's very symbolic with it's one big plus, let's say, in here. So it actually sort of evens out with the same number of positive charges as negative charges. All atoms and molecules want to be neutrally charged. So what happens if you blast it with a sort of stream of energy like this, you shine a light on it with high frequency radiation, what you can do is you can shoot out some of those electrons. If one or two of those electrons shoot out, it won't be neutrally charged anymore. It will be positively charged because it's lacking electrons. It doesn't like that. It wants to be like even-steven, neutrally charged. So what it does is it starts to react with things to get back to zero. So an ion is a charged particle, a charged atom or molecule. So something that has had these electrons shot out from them. It wants to react. And when it reacts, that's chemical reactions we're talking about, that changes this matter. It changes it into another substance. So if you do this with, for instance, if we shoot this energy into the nucleus of your cells, where famously DNA lives, if we do this with DNA, it can change and react, and you will have mutations. I had to think of the word. Sometimes that's the case. Mutations. I was going for mutilations there, but that's not the word that I was looking for. Mutations. And that's not good. Then you can get cancer if your DNA gets ionized. However, microwave radiation doesn't have nearly enough energy to do this. It's just too weak. It can't do this. That's the same for cell phone radiation, Wi-Fi, duct phones, Bluetooth, all of those things. They don't ionize things. So it just cooks you. That's what it does. Because you all have microwave ovens, right? And it cooks things. And microwaves do cook things. It heats you up. And that is the case for phones as well. If you hold your phone up next to your head, you shoot out a little bit of microwave radiation, it will heat your tissue up. It's measurable. It's a very tiny amount, and it's not dangerous, but it will heat you up a little bit. I mean, your tissue will heat up if you exercise as well, or if you step into the sun. So it's sort of on those levels. So it's not a health hazard per se, but it does happen. If you have enough microwave radiation, it will cook you. If I stick you in a giant microwave, then I'll be able to cook you until you die. So that's why we have safety limits. So it won't ionize you, but it will heat you enough so that it's not good for you. We have a little graph down here, I'll show you. This is the safety levels from two organizations. FCC, you may recognize, Federal Communication Commission of the US. ICNIRP is the International Commission of Non-Ionizing Radiation Protection. So they are leading the way for lots of European regulatory bodies in the European countries. And over here we see power density. So that's how much power you're struck with, watt per square meter. So that's how much radiation you get on you. And then we have these graphs like this. So you should look at the lower graphs, in fact, here, because the high ones are for occupational, people who work with radiation and have the right protection on them. So the lower ones, and I'll need to go down like this so you see the frequencies. So gigahertz starts here. Lower here, so right here in this little bowl here, that's older cell phone radiation. Higher than my hand on that side here, that's new millimeter wave stuff, high frequency radiation. So this is 10 gigahertz right there, that's 100 gigahertz. So it's somewhere around, let me do this, it's 10 watt per square meter. Let's take a pin in that and look at 3GPP. What do they say? Well, they have different UE power classes. UE is for user equipment. Those are the phones in the 3GPP world. 3GPP, by the way, are the ones who standardize 5G, and they standardize 4G and famously 3G. So number 3 here, that's handheld UE. And if we look at the power for class 3 over there, it's 23 dBm, which translates into 200 milliwatts. That's the peak value that's allowed. Now, this looks, if you take this together with the safety levels on the previous picture, at first you may see, oh, this is just milliwatts. The previous one was 10 watts per square meter. But then again, if you hold something really close to you, it's not a square meter anymore. It's much smaller than a square meter. So it looks like it could actually be dangerous. That's the point in time where we need to bring the real world into this, because phones never work continuously at peak level, and they can't, then your battery would run out. So there was a big study made a little while ago that looked at how real world phones work and how much power they output, specifically to answer this question. That was their purpose. You know, okay, we see the safety levels, and we see the 3GPP specs, but how much power do they actually put out? So first of all, radiation is aggregated over time. You can't just look at the peak value. So the safety levels for 1G through 4G are aggregated over around 7 seconds. For 5G, it's a little bit more convoluted way of calculating it, but it's sort of around that time, a number of seconds. So in real-world cell phones, radiation is way lower than that, it turns out. So I have 2 graphs for you. I will start with this one right here. CDF means cumulative distribution function. That just means 0 to 100% of the phones. And this down here is how high they came when it came to peak transmission power. And it turns out that quite a few of them managed to peak at around 23. This is around 23, and that's like 50% of them. So quite a few actually managed to peak at that level. You know, try to use what they can. But if we aggregate over time, like this, you will note that the numbers down here are suddenly much lower. 23 is over there, and none of the graphs are sort of getting close to 23. So if we look somewhere around like 100%, it's somewhere around here, like 5, 10, something down there. So whereas the maximum peak was 23 dBm, that's what 3GPP said, that's 200 milliwatt. Since this is a logarithmic scale, the actual aggregated maximum here is around 5, which is 3 milliwatt, which is a lot lower. So then that brings us back way below the safety levels. And even if you're not happy with that, there's history. If you just say, no, I don't believe those numbers, I still think those watts are dangerous, there is the epidemiology. You can look back in time. And we have a long period of time over which mobile usage has grown from essentially 0 to 100%. So this goes back to 1975 to 2015. The green bars are cellular subscriptions, which we can assume correlate with the cell phone usage. And plotted against this is the incidence of cancer generally and cancer in the brain specifically. And if cell phone usage were a surefire way of contracting cancer, then it should be at least a blip in an epidemiology like this. So, now we've talked about 1G through 4G. It seems like there's no good reason to say that it's unsafe. What about 5G? Well, power stays the same. If we look at this old graph that we saw a couple of moments ago, it said class 3, 23 dBm. If we look at this, which is cut from the 5G standards, from 3GPP, this is just a very little snippet from a large amount of tables. These are frequency bands right here. I just chose a few. You see the maximum total radiated power is again 23. So it's the same power. Frequency does go up. So higher frequency radiation does behave differently from lower frequency radiation. It, for instance, penetrates less. It doesn't go through walls or trees or bodies as well. It reflects more. Your body is more of a mirror to 5G radiation than it is to older cell phone radiation. All the time when I say 5G radiation, by the way, I mean the higher frequencies. 5G can use lower frequencies as well. And then I'm just back to the whole reasoning of the lower frequencies, just so that you were sort of on board with that. I'm talking about the new things with the higher frequencies, famously called the millimeter wave frequencies. But it's still not ionizing. It still doesn't come close to breaking apart the atoms and molecules, shooting out those electrons and making them charged. Not even close. There's something in 5G that is kind of new. That's beamforming. That is concentrating the transmitted power in a particular direction so that we can shoot it at one phone and not all the other phones, which is super cool. As an engineering feat. If it also killed people, it would not be super cool. But just as an engineering thing. This is not to nuke people. This is essentially just to concentrate the power on you and not waste it in other directions. Because if you shoot power at me and the same signal also goes all the way around me, we don't use that power. So the idea is not to raise the power in your phone. However, it could potentially be used to raise the power in your phone because we do concentrate the radiated power. But then again, I have to go back to the fact that the previous reasoning I had was for total radiated power, all directions. When I said previously, what if you hold up your phone and all those watts sort of go into this little square of your head right here? Well, you may not have thought about it, but I sort of almost assumed beamforming already then, that the whole amount of power goes into whatever is facing your skull. That's, of course, not usually the case. A lot of it goes in other directions. With beamforming, more of it can go to your skull. But I'm just pointing out here the fact that the reasoning and the mathematical numbers that I have already were already assuming that all that power goes into you. So it's still below those safety levels. So, rumors. People say things about 5G. What about the dead Dutch birds, for instance? Did you hear about the dead Dutch birds? I'll tell you. Did you know that a 5G test in Netherlands killed 297 birds? Are 5G tests killing birds in Holland? Did a 5G experiment prove fatal to birds in trees? 5G experiment killing hundreds of birds in the Netherlands. Hundreds of birds dead in The Hague. Or hundreds of birds dead during the 5G experiment in Netherlands, says Captain Planet. Now, Captain Planet also says this, by the way, in that same article. It ought to be noted that 1 gigahertz is 1 billion oscillations of energy per second. What do you get? No wonder the poor birds probably died from heart failure. I'm making a little bit fun of Captain Planet here, and that's by design, because I think it's reasonable to do so. It would be fun to talk to Captain Planet just about large numbers. Choosing units will allow you to make numbers arbitrarily large. I'll go to Captain Planet and tell him, do you know that I'm almost 2 trillion picometers tall? Trillion! It's also funny that he multiplies oscillations per second with gigahertz, which gives you frequency square, which is an unusual unit of measurement in this case. It would essentially be frequency change per time, would be the engineering interpretation of that. I don't think that was Captain Planet was after. The point is, I'm bringing this up as one example. There are lots of them, all of these relating to the same incident or claimed incident, alleged incident. But there are lots of them, so I'll just bring up one. So, what about the dead Dutch birds? Dead? Yes. 5G? No. There was no 5G there. The birds died, but there were no 5G tests near them. At least no one has come forth and said they were testing 5G. No authorities did it, no operators did it, no vendors did it. I can't claim, I can't prove a negative. I can't prove that there wasn't a guy with like a 5G network in a suitcase sitting on a bench in that park. But no one has come forward and said they did just that. So what killed them? Well, then we need to take this magnificent aspect of science and say we don't know. That's something that is okay to say. We don't know what killed them. Before science, that was taboo to say you don't know. Then you have to say, yes, we know exactly how the world works. If you go back 500 years in time, the scholars knew exactly how the world works. And now we don't know. There were investigations. The best of them seemed to guess that they might have been poisoned. We don't know. If you're really cynical about it, you could sort of hypothesize that the person perpetrating this hoax and claiming that it was 5G that killed them also poisoned them. But I won't start a conspiracy here because I just don't know. They died. I don't know why, but it seems it didn't have anything to do with 5G. So, what about the WHO, not the band, the World Health Organization? They're classifying cell phones as carcinogenic. Did you know that? That's also been widely reported in the news. Okay, so do they? Well, kinda. First, I'd just like to say that the World Health Organization has a history of not 100% scientific rigor when they make decisions on things. I won't go more into that. I happily have a discussion about that, sort of on the side after this, and take that discussion. But more importantly, I don't need that as an argument right now. I just wanted to put that forth. There's sort of a love-hate relationship between the scientific community and the World Health Organization. But we don't need right now because we can just look at the face of it and see what they say. Because they say radio frequency electromagnetic fields is possibly carcinogenic. They don't say cell phone radio frequencies. They don't say 5G. They say radio frequency electromagnetic fields, which is a lot. I mean, it's difficult to get away from radio frequency electromagnetic fields. Just for fun, I looked up the Wikipedia page on the 50 kilowatt radio stations in the United States, and turns out there are hundreds of them. 50 kilowatts. Do you remember the power numbers we saw before for the cell phones? Watts and milliwatts. These are 50 kilowatts radio stations. Also, they have more than one list. There's one list for carcinogenic, one for probably carcinogenic, and one for possibly carcinogenic. Now, EM radiation is the one on possibly carcinogenic. And if you just say, you know, the World Health Organization is saying it's carcinogenic, maybe you're not telling them that it's on the possibly list. Still, what does that mean? Could there be other things that are possibly carcinogenic? And it turns out that it's a long list. There are things there. There is aloe vera, which goes nicely on your skin. There's caffeic acid, which goes nicely in your coffee and in your body, and there's being a carpenter, which goes nicely in your religion. So let's just say that when someone says, did you know that the World Health Organization is saying that cell phone radiation is carcinogenic, that is extrapolating what they're saying wildly. I think you agree. Non-humans. I'm not talking about aliens here or weaponizing 5G to protect from an alien invasion. What about technology? Could higher frequencies affect technology? This is sort of a sidetrack here towards the final half of this. So this is not about the health of humans, but about the health of things that humans use. Higher frequencies could absolutely affect technology. It would be disingenuous of us to claim that it couldn't, because different frequency radiation affect matter differently. That's just the case. For instance, it has been suggested by the meteorological community that this could be a problem, because it turns out this millimeter wave range is covers the absorption frequency of water vapor and oxygen in the atmosphere, which in turn would possibly lead to problems with satellites, you know, with weather reports or weather alarms, those kinds of systems, which would be not good, specifically in times like this, when weather with climate change and everything is becoming more and more alarming. That would be bad. The only thing that we can say here is that 3GPP seems to have looked at this. They seem to have seen this graph. This is the 10 gigahertz to 100 gigahertz. We see water and oxygen right there. And if we look in the 3GPP papers, this is again a snippet here. You won't need to look at all those numbers because there's a note here and I have magnified it. So this is just number of frequency bands essentially. And they're saying, note 2, this particular frequency range is protected in order to protect satellite passive services. And it turns out this frequency range is exactly the absorption frequency of a water vapor in the atmosphere. So they have thought about this. So our conclusion is essentially this is real. It looks like 3GPP at least have thought about it. We have no idea whether this is enough or not, or whether this will be a real problem. So this is a stay tuned issue essentially. And there could be other things. We heard about this meteorological, which sort of tried to research and find what problems there could be. And this stuck out. And maybe there are other technical things that will be affected by high frequency radiation that I don't know about right now. Internet of Things. That's a popular thing to talk about, right? What about the Internet of Dangerous 5G Things? Well, 5G doesn't inherently lead to more radiation. It sounds like, you know, one more than 4G, but then again, that's not the case. It's the same amount of power being transmitted. All radiation drops at the same rate in vacuum. It's the inverse square law. If you double the distance, you will sort of diminish the power by 4. If you triple the distance, it will go down by 9 and sort of spreads out over larger and larger spheres like this. So it drops at the same rate in vacuum, but different frequency radiation does absorb differently in material. So higher frequency are absorbed more in matter, which means we won't be able to have base stations that cover the same amount of area that we had with maybe 1G, 2G, 3G, or even 4G. So there will be more base stations, but they don't need to have power high enough to reach, you know, kilometers and miles away, because, you know, by definition, they can't go through things that far, so they only need to reach a small distance. So the total power output pretty much stays the same. More base stations with less power. This is also from the 3GPP specifications. BS is for base station, wide area, medium range, local area, and you will see the numbers over there, and those numbers are not 50 kilowatts. They're 50 watt for medium range and 2 watt for local area. It may look weird that a wide area currently has, oh, here you go, no upper limit. But then again, 3GPP work in conjunction with the regulatory authorities, the ones who really set the limits for how much power you are allowed to output. So they're pretty much in the business of making sure that you're not allowed to put out harmful amounts of radiation. What could possibly happen is that we start wearing things. As far as I've seen, when I've read, I can't see anywhere any recommendations on how many 5G phones or any kind of phones that you reasonably should carry with you. Because the numbers that we've seen, they are per UE. So if I start carrying around 10 UEs, that's user equipment, remember, the phone in 3GPP parlance. So if I carry more, start wearing things like this guy. This looks too old. We need to move forward in time. This cool guy, remember this? Still too old. Maybe it will be this. This is things that you probably can buy today, and they could all be connected with, short-range radio technologies like 5G or other technologies. Nothing special about 5G. It depends on the frequency just. So if we start wearing, tens, hundreds, thousands of these radiating things, I mean, it does add up. That's just math. So I haven't seen any recommendations for that, and I haven't seen anyone wearing 1,000 phones yet. But again, this is us just trying to sort of figure out what will happen in the future. Who knows? People are crazy. Maybe they will do this. So where does this leave us? Well, after our research, we have found that you don't need to panic. It seems like there could possibly be small effects. We don't know. You can't prove a negative. But then again, it seems that if there are effects, those effects are small enough to be hidden by everything else in life. You can think about it this way. What could be more dangerous than gigahertz microwaves? Remember Captain Planet? He was upset about billions of oscillations per second. What if you said, I'm going to beam you, Mr. Planet. I'm going to beam you not with billions of oscillations per second, but with trillions of oscillations per second. Scared now? Well, what happens if we go to trillions of oscillations per second? Well, what if we start over here? This is microwaves. If we go to even lower frequency, longer wavelength, we hit radio waves here. So microwaves, that's where we are. And if we extend this like this, we get shorter wavelengths and higher energy. That's how physics work. So we start here at the dangerous 5G frequencies and then move up like this. We hit infrared. That's remote controls. Or even more dangerous, then we come to visible light. Wonder if Mr. Planet is scared of visible light. And then we move up here, then we hit ultraviolet, X-ray, gamma rays. And even if Mr. Planet isn't scared of visible light, he might say, but you should be right, because you're out in the sun, and if you're on the beach, you need to wear sunscreen to protect you, otherwise you get skin cancer, right? Yeah, you do. That's real. UV A, B, and C that you see on these sunscreen bottles are just different parts of the frequency spectrum. You can point out UV A, B, C on this scale right here. And it turns out that that frequency is ionizing, because at some point in time the frequency or the radiation gets high enough energy to actually shoot out those electrons from the atoms and molecules. Make them charge, make them react with other things, create mutations, create cancer in your cells. But it starts here. That's why you need to protect yourself from the UV light. Down here, it's pretty okay. It's just a matter of balance, right? It's benefit versus cost. Cost benefit. What do we get? What do we need to pay? What if I offered a new service to you? And I said, I have this new service for you. It's super convenient, really. It's going to change your life for the better. Has some drawbacks. It will kill 1 million people each year. It will probably injure or disable tens of millions of people each year. And as a coup de grace, it will kill and disable people who both use and not use the service indiscriminately. Interested? You might not be if I'm trying to sell it to you right now. But I'm sure that several of you watching right now are saying out loud to your screens in front of you, well, I know what this is because, hello, cars. This is cars. And granted, it's even more dangerous if you do it the Mr. Bean way. But even if you don't do it the Mr. Bean way, cars kill people, they injure people, and they kill and injure people who are not in cars. However, cars also save people, right? There are ambulances and fire trucks and police cars. And you can say the same thing with phones. What if phones actually had a demonstrable negative effect, which it actually doesn't right now? What if it did? Maybe phones sometimes save people? I think you can think of examples where a phone could actually save the lives of people. So, my conclusion is, it's risky business just being alive. Don't let that stop you from living. Me. Thank you very much. We've been talking for 44 and a half minutes right now, so I think I'm right on schedule here. I wonder, Søren, are there any questions that have popped up during the talk?
Yeah, this is your moderator speaking. I hope you can hear me. I think that was pretty clear, Martin. Thank you very much. There are actually 2 questions.
Excellent.
One starts with a statement.
All right.
The beam forming makes radio signal for LTE or new radio much more powerful than regular antennas with MIMO 2x2.
Yeah.
And I think you talked about that.
Yeah, it does. And the point that I made there, I mean, you're absolutely right. And the point that I made is that the regulations that I showed you were for totally radiated power. It's a TRP. And that is all of the power that goes out. So even if you cram all your energy of that beam into a very, very thin, pencil-thin beam like this, it would still sort of be below that level. If you start not beam forming, that's when the powers will really drop from that level, because you will start spreading the power out all around the different directions. So I can just say that I agree.
Yeah, and the question part of the question, and this may be a tricky one, but I'm going to ask you anyway. What will be safe distance for human beings from site with 5G new radio on 3.5 gigahertz with 64 by 64 massive MIMO?
I absolutely could. I couldn't say. What I would do, but first of all, I can't do the math in my head, so I won't do it right now. What I would do is this. I would take the maximum allowed output of the base stations, because those I showed you those numbers. So it depends on which class of base station this is, whether it was wide area, sort of medium or local area, because they have different maximum output power. And then figure maybe it's outputting at that maximum power, because base stations are allowed larger output power than phones. And then I would start calculating, I would sort of make an assumption, I think, of the beam, sort of how wide that beam is. So maybe going out in a 15-degree angle in both X and Y like this, possibly. And then I can start to do the calculation. How much does the output power diminish over the distance? And at some point, I will hit the safety levels given by the FCC and the ICNIRP. So I think I have a mathematical way of moving forward with answering the question, but unfortunately I can't do the math in my head, and I don't know. I have absolutely no gut feeling right now about that.
Okay, fair enough. I think it's a good answer. Next question is kind of related. Are there any good studies about the effects on base stations antennas on people who live next to them? I think that was almost the study you were improvising.
But almost, albeit I did it like just mathematically, and you could do it with studies instead. Well, first I'd like to just note one thing that I probably didn't mention. The reason that I'm here speaking right now is that I wrote an article about this. I think it was published right before summer, if I'm not completely mistaken. And we published it in our social media, in our web pages, and so on. And that article was, I don't know, 10, 15 pages or something like that. And it had, at the end of it, lots of references. There are, I think, at least 3 pages of references that I used researching that article, and then I've used that article as a basis for this talk today. So I would first off go back to looking at those articles and see, did I read anything about that? I absolutely believe that there are studies like this. I think you can find it on PubMed. I don't off the top of my head right now, I can't point to a particular link, but look at the article. If you're really interested, it's an excellent question, by the way. I mean, these are the things that you should look at, but you would remember, you would need to look at not just one study. You would need to find some kind of sort of corroborating evidence where there is a consensus where people living near this base station get cancer. Okay, then people living near exactly identical base stations in other places should also get cancer. Those kinds of studies, that's what science does. So if you're super interested, get in touch with us at APIS, and I'll be happy to see if we can find something together. But I don't have the link ready for you. I would need to search for it.
Okay, thank you, Martin. Another good question here. What about accessible measurement devices? Would that be a way to calm down general panic, allowing general public to measure power density? So, are you aware of any?
Excellent question. So I have a 2-parter answer for that. First, unfortunately, no. I mean, this is not what we do for a living. We read papers and try to figure out how science works and communicate it. We're essentially science communicators. We don't really go around the city measuring these things. So I don't have a particular product that you can use. How, unfortunately, or maybe fortunately, I don't know, I really don't think it would help at all, because that's just a number. And if I say, well, here's a number and it's below this other number, then someone who thinks this radiation is dangerous will just say, well, that other number is wrong. The FCC or the ICNIRP, they're paid off by Telia and Ericsson and Nokia and Alcatel and all the vendors and operators in the world. So there is this layer of conspiracy theory in this, there's a strong element of that. I think I can maybe finalize that answer by saying something that's always useful when you try to convince someone of something, that if the person that you're trying to convince hasn't reasoned themselves into believing the thing they believe, then it's very difficult to reason them out of it. Because it's a very engineering way to think. What you're saying, yeah, I can show you here, look, it's below, it's the number, it's below the levels. But that person didn't come up with that belief because he has sort of studied engineering or radio technology and have seen too high numbers, or he's in the medical field. He came up with it because he read it on Facebook, or his friends said this is dangerous, or there's some other kind of scare being thrown around. So I don't think that is the way to help. I think you need to sow seeds for understanding and have discussions and ask these people. So are there any other things that you don't believe in? Do you believe in the Tooth Fairy? Do you believe in Santa Claus? And then you can ask them, so why don't you believe in those things? And then you can start finding common ground for how to evaluate reality, essentially. I think that's a much more fruitful way of going forward than sort of throwing hard numbers at them and saying, look, here it is, you're wrong.
Yeah, that's a good point. And maybe just presenting a nice measurement device for people would actually cause them to be
Yeah, if you see,
even more afraid
here,
of.
here
Like,
is
we have
the
to
current
measure
level
things.
of 5G radiation on the central square in New York City. I don't think that's a good thing. That's also an excellent point, Søren.
All right. Yeah, finally, so far, kind of more technical question, I suppose. For mobile terminals, there are SAR and connect values. Have you heard about them,
Yeah,
Martin?
sure.
And what do they really indicate?
Well, I'll have to first confess my ignorance. I don't know about the connect value. SAR has been around in the mobile world together with me in the mobile world the last 20 years. SAR, I believe, is for specific absorption rate. So it's how much of radiation is absorbed by your body. So when I showed you power density, like power over square meter, they try to do the same thing, measure how much radiated power hits you. But they do it in different ways because SAR is based on volume. It's based on like a kilo of your flesh, essentially. How much do we heat up a cube of you? Whereas power density, watt per square meter, measures how much do we heat up a particular part of your surface area. And there is a reason for this change, and that's because when we move into higher frequencies, to a larger degree, it reflects off you. It can still affect your surface, but measuring how much you are increasing in temperature sort of inside that surface may not be the right way to measure. So that's why, to some degree, power density is replacing SAR. I've even read a number of scientific papers that say you shouldn't even measure like power like that. You should just measure degrees. How many degrees do your cells rise in temperature? Because that's what happens. You get heated. That is exactly what happens. You are heated up. So why sort of do it in this convoluted way and say you're hit with this amount of watt per square meter or like cube or something. Let's just say you are heated 1.5 degrees centigrade or Kelvin. So again, regarding the connect, I don't know what that is.
Fair enough. That's a good answer too. Sometimes, particularly if you do not know.
Yeah, particularly then.
All right, that was the last question from the question and answer function.
All right, excellent. So I'm wondering, Mache, do you want to say a few words here towards the end?
Thank you very much, Martin.
Yeah.
Well done.
Thank you.
Well done. I hope you guys enjoyed this webinar as much as I did. And thank you, Søren, for being the moderator today. Very impressive. Make sure that you guys visit our website. There you can sign up for our newsletters. You can even chat with us. You can follow our social media to make sure you don't miss any news like webinars or other updates. For now, I will thank you all and have a nice day. Take care. Bye.
Bye now.